is Rita Mwima, and I carried out this study that is aimed at creating a habitat suitability model that shows areas that are more prone to the survival of this bacteria. And the study was carried out in New York State, USA. So I'll start with explaining what zoonoses are, because this is a case study of zoonoses. So zoonotic diseases are those that are passed on between humans and animals, and at least 61% of human pathogens are zoonotic, and they represent 75% of emerging pathogens that have occurred in the last 10 years. For zoonoses, it's important to know the reservoir and the dynamics of how the disease is transmitted. And that's why we need decision support tools to guide us in preventing and controlling such diseases. Listeria is a highly fatal foodborne disease, and you know how foodborne diseases are very important in the Western world where they eat ready-to-eat foods. It's caused by Listeria monocytogenes bacteria, and it's acquired when one eats food that's contaminated by this bacteria. It's commonly found in food and the environment, and it survives in a wide range of environments, and that's why we took time to do this research. Our objectives were to find out the most influential habitat factors that favor the survival of this pathogen. Since it can survive in a wide range of environments, we wanted to find out the most important factors that favor its survival, and then come up with a model in form of a suitability map that shows where this pathogen survives the most, and then find out which factors affect the uncertainty of these locations. So to find out the most important factors, we carried out a classification and regression tree analysis. We considered meteorological and environmental factors like the soil, type of soil, the amount of water in the soil, proximity to lakes, water sources, proximity to forests, and many others. And when we carried out this analysis, we came up with this table. And from this table, we can get the scores for each factor, like it's seen here. These are a few of the factors with their scores. And from the scores, we got their weights, which show how important each variable is compared to the other. And from this table, the shallowest depth to a wet soil layer had the highest score and the highest weight, which showed that it was the most important factor in determining the survival of this bacteria. All the habitat factors were presented in form of raster map layers, and they were all standardized to a common scale of 0.0 to 1.0, where 1.0 represented highest suitability and 0.0 represented the least suitability. After finding out the most important factors, we carried out a multi-criteria evaluation using weighted linear combination, and we did this to come up with a map that shows those areas that are most suitable. And that's the map. The purple areas represent the most suitable habitats, and then the brown areas represent the least suitable areas. So from this map, we needed to find out which factors contributed the most to those highly suitable areas. So for each of those areas, the brown area up there, I used a pie chart to show how much each factor contributed to the suitability in those areas. And from these pie charts, I got the 10 most important habitat factors to consider. And to validate my model, because this map is now my model, but I have to validate it and prove that those are the most suitable areas, and the factors that contribute to them are really the right factors. So I carried out uncertainty and sensitivity analysis using the integrated uncertainty and sensitivity analysis tool, basically for model validation, to find out the variations in this model and determine which factors contribute to the variation. And for uncertainty analysis, the result was a suitability map, an average suitability map, and an uncertainty map. And when I analyzed the two maps together, these red areas show highest suitability for the suitability map here, and then this red area shows highest uncertainty. So when I analyze them together, this the upper part shows highest suitability, and then this part shows highest uncertainty. So highest suitability with highest uncertainty shows that, well, it's suitable, but why is there so much uncertainty? And that's why I had to analyze the factors again to find out which factors contributed to this uncertainty in these areas that are very suitable. So to find out those factors, I carried out a sensitivity analysis and came up with first order index and total effect index map for each factor. So for sensitivity analysis, the maps would show me the most important factors that contribute to these uncertainties. And so from this map, this is the first order index map that shows that the slope, proximity to water, and shallowest depth to a wet soil layer contribute the most to these uncertainties that I talked about previously. And then this map, this map is a total effect index map that will prove that proximity to water and the shallowest depth to a wet soil layer contributed the most to the uncertainties, which proves that the bacteria can only survive in areas that are moist. Wherever there is water, that bacteria will survive. And then the slope, which contributed the least here, but contributed a lot here, shows that it can only be considered if it's involved in interactions with all the other habitat factors. So from my study, I proved that proximity to water and the shallowest depth to a wet soil layer contribute the most to the survival of this bacteria. The slope contributes a lot if it's involved with other factors. So if it's involved with proximity to forests, it will contribute a lot. But if it's on its own, it can contribute a lot to the survival of this bacteria. So in summary, I compared my results with the studies that have been carried out on this bacteria, and all the studies confirm that moist, warm soil contributes to the survival of the bacteria, which proves my results. In conclusion, the most influential habitat factors were those that are related to water and the slope gradient. And therefore, there is need to maintain water quality of the water sources, especially since this bacteria is transmitted through food to humans. There is need to make sure that the water that is used in the industries and the water that is used in irrigation is very clean. And there is need, because the slope contributed a lot, there is need to ensure that soil water runoff is controlled. And then there is need for collaborations of between different disciplines. For example, I'm a computer scientist. I worked with vets to come up with this study, and I also worked with people from SEDA to come up with these results. And for future research, there is need to predict in real time, because this study was carried out in 2010 and 2009. And this study can also be used on other zoonotic pathogens. So people were asking why I carried out the study in New York State, but that's where the funds were available. But we can also use the same tools to predict where zoonotic diseases can occur here in Uganda.
Let's have feedback for Rita. Feedback. Lunchtime feedback.
One question. And a simple one. I'm just wondering why you did have to do this for New York State and not anywhere in Uganda where
funds.
Just mention. I was sleeping.
So let's put our hands together for the dead. Thank you for feedback. Lunch is ready.